So welcome everybody. This is the final episode of the 2024 season. So thank you all for joining us. We've had some really good discussions in the previous three, and we hope that tonight, even though the crowd's a little bit smaller, we'll still have some really insightful discussions, some probing questions, and some interesting answers to those questions. So I would like to thank my co-workers on this, especially Bernadita Salato and Mario Mirando Sazo. Both of them have put in an inordinate amount of time to make this a success, and they are owed a round of applause for the work that they've done because it's been a success due to their efforts. But that's not to slight any of the rest of us who've worked on that. I want to thank my co-host tonight, Emily Lavely. She's going to jump in with questions too. As things move along, if something comes to mind, she's going to jump in and maybe even redirect the conversation as we move along. We want to thank our friends up in Canada who've joined this year, Caitlin Hengel and Christy Greg McGovern and Lindsay King. Thank you for bringing another country into this. You were participating some last year too, but really appreciate the different perspective that you bring, especially when it comes to regulatory things, because it provides some insight in how things can be different here in the U.S. and hopefully vice versa. So I'm going to go ahead and cancel this slide and stop screen share and go back to just our panels here. We have a number of people who you recognize if you've attended these meetups before. They've returned and they're specialists and growers. We're thankful that they came back so that they can offer some insight. And we got a couple new faces as well tonight. So I'd like to start off by asking Dr. Shackel if you would like to introduce yourself a little bit and talk a little bit just about what's going on and what brought you in this evening.
Okay, nice to be here. I should mention to begin with, though, that I think these questions that you asked in surveys were really great, and the responses were very encouraging to me. And I also love questions. So I am going to start. So I'm going to start with this and just say that I think that this model that you're seeing here, I assume you can see my pointer?
Yes, we can.
That really the worldwide paradigm for irrigation management tends to either focused on soil, water in the reservoir, or maybe in the atmosphere and how much water it's demanding from the tree. And I would propose a modest proposal here that this kind of focus on how to manage irrigation, it might work reasonably well in some conditions, but I think that the fundamental concept of looking at the soil as a reservoir and the atmosphere as the demand that the reservoir is filling is pretty much not applicable to variable soil conditions and things like drip irrigation and localized irrigation. I can stop right now and ask for if anybody disagrees with that. So how's that for asking for questions?
Yeah, let's start with that right now. So anybody who's a guest, you should be able to unmute yourself if you have a microphone. If not, in the chat, just indicate that you would like to ask a question and we will unmute for you. But by all means, let's get some discussion started here.
Dr. Shackel, can you explain a little bit about why you kind of came to this conclusion and what's changed your thinking over the years?
Yes. It's related to measuring the plant, which is kind of what I'm going to talk about. But when we've measured the plant, in most cases, we've found that even though, for instance, we're matching ET, we may still be stressing the plant. In other cases where we don't match ET, we may not be stressing the plant. And it's not surprising that And I've generally found that even though we've made detailed soil moisture measurements with neutron probes and so on, that we found almost no relation, other than very, very broad relation, but almost no relation between what the soil moisture is and what the plant moisture is. But I think it makes sense that once you start irrigating with, let's say, drip irrigation, then it becomes very problematic where the soil sensor needs to be placed to tell what the average soil moisture is. And then even worse, even if you know what the average soil moisture is, that may not be the moisture that determines whether the plant is stressed or not. So other than those few things, I would say that, you can just look at the soil if you know where to measure it, or look at the atmosphere, and you may come up with a reasonable number. But the more we look at it, the more I'm convinced that neither of those things is, both of those things can be very misleading. But I'm kind of interested in whether people agree with that, or if people say, no, I use this religiously and it works every time.
Well, based on the results of the poll, I don't know if you remember, but 75%, I think, said that they manage their irrigation based on ETC. So I will assume that it's a large proportion of people that will be surprised, at least, with your comments. I'm not saying I am.
Just because many people use it doesn't mean that they think they're right. I mean, I don't mean to be too facetious about that. And one question I think you need to ask is, how do you use ET? Do people do it very exactly, or do they just say, well, it's going to be warm tomorrow or next week, and so I probably need to irrigate more? All of those things could be regarded as using ET. Does anybody have any ideas about how growers use ET?
Well, let's open it up to the growers that are here. Does anybody want to volunteer an answer to that question? Do you actually rely on that?
You could have a poll. You could say, how do you use ET? Literally, sort of ballpark. Anyway, go ahead.
Yeah, you can just unmute yourself, or if you want to put something in the chat, if you don't want to verbalize, go right ahead. We're kind of curious.
Yeah, I use ET to schedule irrigation. I take it fairly literally. I do discount drip quite a bit because I don't think drip irrigates the entire orchard acre. So like, I'm not going to put on the volume of water through the drip that I would using sprinklers that does irrigate the entire acre. So I do adjust the calculation for that. And then depending on observations in the field, I might only irrigate 90% of ET on one block, but maybe 110% of ET on another block and stuff like that. So I do use it as a guidepost to get started, but try to tweak it and play with it. And then my only other concept about the soil focus thing is, if you have a weak soil that can't hold a lot of water mixed in with heavier soils, we try to manage to the weaker soil. So that's a way to adapt that concept as well a little bit, I think.
Paul, can I ask you a quick question? How did you arrive at your fudge factors there?
It's a lot of observation in the field and just saying, yeah, wow, these trees look a little drier. The soil just seems to be a little dry still, or the fruit size isn't where I want it to be. Oftentimes, so that's a fruit size thing.
Okay.
Yeah, I think that's actually a good illustration of calibrating one of these methods or another of these methods to ground truth that you see as a grower and what kind of results that you're getting. If you manage, one question I would have is, if you have one irrigation set and you manage it to the soil, let's say the gravel soil that doesn't hold much water, do you end up over irrigating the other soil?
So Professor Chuck, we had that variability, at least next to Lake Ontario. It's a huge variability. So for me, it's super, super crazy, the effect of the soil and the cloudiness of everything, the stress, the shading, overthinning, the heat, whatever. It's crazy, the weather. So here I can really experience the use of that technology, whatever sensing with the plant, and in connection with the atmosphere and the soil, of course, whatever precipitation we can get there. But we need to know when we need to stop irrigation in honeycrisp under our condition. And what is that soil moisture that we need to make sure that those roots are there, so they're fresh when it's very hot in the summer. It's gonna be hotter. It's gonna change. So we're starting with some nettings, some nets, but not like in Europe or not like in Washington. Washington, you had to have at least 8,000, just 8,000 acres, perhaps no more than 10,000 or 15,000 acres of coverage orchards, apple orchard, for the amount of acreage that is planted there, So that's gonna be a mitigation. I don't know. Brunella was saying, I don't know where I read that we could get until a 30% water savings if we know how to irrigate at least the apple orchards, so perhaps we're using too much water. And if we relate that with fruit quality, I think so that is what is happening in Washington, definitely. That kind of, there we're sensing, I really think Professor Shackel make a huge contribution, because we can see a pattern in our soils, at least here, the variability, looking for that variability, where I had drought, where it's too wet, whatever. So I can figure out how to manage the water, how I can grow cherries or sweet cherries, but without irrigation in the Northeast. I would like to know that. I'm gonna kill the plant is not gonna bloom. I don't know, so we really need to do a lot more science in the Northeast in irrigation. It's just the beginning.
Yeah, you're preaching to the choir here, but when you say more, more science, but there's one very big problem, and I'm curious about everybody's perspective on this, is if you have variable soil, how do you manage the water? Do you change the irrigation system to match the soil? You probably make smaller irrigation sets, but bottom line is you're going to have an irrigation set that you're going to have to irrigate everything. And so how do you deal with that?
Dr. Shackel, can I interrupt just real quick? That is an awesome question. Can you stop screen share so everybody can see the speakers a little bit better? We're stuck on postage stamps. We can come back. I'm assuming you've got more interesting stuff.
I've got a lot more, but
I bet you did. Brian, you got your hand up about this.
So this has been our challenge on our farm, because we go from gravel to Brookston clay. Because again, we're on the other side of a lake. We're on the north side of Lake Erie, so we have that wonderful gravel that is self-draining, and then we have that beautiful Brookston clay that turns into road cement by the end of the season. And especially if you've over irrigated it. What we've found is going to the smaller sets, and I've got 250 acres now under irrigation. That's everything from apples, peaches, pears, cherries, tart and sweet, tomatoes on drip irrigation. And I have found that smaller sets, that ball valve that you put at the end of a row is the most valuable tool that you actually have in irrigation. And then the second one is the shovel. I like looking at root structure, see what the roots look like, see where the fine hairs of a root are, and knowing if my water's actually there, if there's a water capacity. I've often thought of the tree as a straw, less than like the ability to take, and I loved the soil is a reservoir of water, and we need to keep the reservoir there and happy, so that the straw can pull the water up into that tree so it can keep its capacity. It can. The one thing I haven't noticed yet, or anybody mentioned, is water quality. Has anybody really looked at the cations, the pH, the ability for the water to buffer, and all that kind of stuff to make sure that it's working, that it can work for irrigation.
So, Brian, I think that before we go into the water quality, which I think is a really good question, I would like to go back to the question posed by Dr. Shackel about the variability, how we manage that, and just to share about what we experience here in Washington, in mostly what Paul mentioned, that which we do have a large variability, but not only in kind of aerial image variability, if I can explain that better, but also within the profile. So we do have that variability of layers that change the flow of water within the profile. And I believe that most growers will follow the guidelines of irrigating based on the most limiting area. But again, that leads to over-irrigation in other areas. So going back to your question related to variability.
So I have a question and a comment for you, Dr. Shackel, because you are a professor and know more than me. But so like if the soil has, just for an example, like 1/2 inch of holding capacity in one area, but on the top 2 feet, let's say, like really low. And then the other area has like 3 inches of holding capacity on 2 feet. If you just put in a 1/2 inch at a time, the weak soil should be able to hold that, like up to a 1/2 inch, right? And then you just irrigate to the ET, but make sure in any single shot, you're never exceeding the 1/2 inch, but then you're just irrigating the ET. So in theory, that should never flush through the weak soil, and you shouldn't be over irrigating the heavy soil either. Like you're putting the correct amount of water on both of them. But in order to achieve that, you probably need to irrigate shorter sets and more frequently, right? So I don't know. That's the theory of it that I've been explained, and it makes sense to me, but I just wonder what the pushback on that is.
Well, so that's an excellent point. And you're right, that is the theory. And that actually is sort of the theory to drip irrigation from the very beginning. That is that if you drip and drip often enough, you avoid all these issues with soil variability because you're just using the part of this, what the trees are using what you put in. I've never tested that directly, but I can explain something that we found in walnuts that I think is relevant to this. Part of the question is when you start irrigating. When do you start your irrigation season? And in walnuts, we have crop coefficients. Maybe you know, or maybe you don't know, the walnuts tend to leaf out much later than many of our prunus and crops. So, the prunus species may be leafing out in March or something. Maybe almonds come even before that or bloom before that. Whereas walnuts might be April, beginning of May sometimes. And by that time, in this climate, you're getting hot days. The soil surface is looking really dry, maybe cracking. And so as soon as the tree leaves out, technically the crop coefficient begins. And so walnut growers were starting right at leaf out or even sometimes before because they thought the soil was dry. Some growers were seeing a lot of water stress in their walnut trees during harvest when they cut the water off to harvest the trees because they're all harvested mechanically. So we had one of our extension specialists, Bruce Lampinen, was pressure bombing the walnut trees that where growers were having other quality problems. And he was associating those things with starting too soon in the springtime, starting to irrigate too soon in the springtime because the trees were measuring wet. That is what we call the baseline. They were measuring about as wet as the tree could be under those conditions early in the season, and yet growers were already starting to irrigate them because ET was picking up. So, and what we found, this is a long story and I don't have the data. I didn't bring the data with me for this presentation to show this example. But what we found was that if we measured the plant and waited to irrigate till the plant indicated that water was necessary, and not by a whole lot, but just, okay, we're just beginning to get dry, the trees were less stressed at harvest and healthier looking. And my inference from that is when you irrigate, so in your case, when you've got a soil that holds a lot of water and you've got winter rainfall, then that lower profile of soil is going to be pretty wet. And if you begin to irrigate the upper part of the profile to match ET, you're going to keep that lower part of the profile wet for a longer period. And that could actually inhibit root development down there. That would be important for us anyway during the time of harvest. Now, you know, this is it's not apples and pears like what you guys grow, so there may be quite different parameters to be concerned about. But it made me think anyway that starting too early and this idea of having a good soil and irrigating it small amounts, but to match the ET when you're trying to get the poor soil to perform could still be shooting yourself in the foot in some cases. But you won't know that unless you measure the trees to find out whether they're wet or not. So sorry, that was a long answer, but.
Super interesting. Thank you.
I see Alan's got his hand up. Who's the moderator here?
I'm moderating. I don't see the hand, but Alan, if you've got a question, hop on.
Oh, wait a minute. Oh, no, that was my hand. Never mind. I didn't realize that. I don't know how that turned into a hand, but it's turned into a hand. I'm sorry.
Did you want to ask yourself a question?
No. I didn't raise my hand. I don't know why my cursor turned into a hand when I moved it on the screen. But anyway, okay.
Hey, speaking of soil capacity, soil moisture, and so forth, Molly, in the previous meeting, you mentioned that you put your irrigation lines under plastic. Is that correct? Did I hear you correctly on that?
Yeah, I did mention that we've been changing the way we do our new plantings, and that specifically was for our replant blocks that we were running the double drip lines under plastic, like people might run a T-tape under plastic for vegetable production. And we were replanting the first year in the heat dome. So obviously not a lot of cover shade for the soil. Things were very hot and very dry, and without much root on the young plantings, we were concerned as well about the amount of water that might be required to even just service that, those first couple inches of soil. So we had thought to try this along with other, benefits in that, ideally holding and spreading out some of the moisture over the mounds to retain water, but also provide water sort of throughout that area where the rooting would happen, but then also for weed control and trying to just minimize some of the other orchard activities and disturbances that we would be making. We did find, sort of, again, just observation without measurement, but our observation was that the soil did retain moisture longer and more consistently than the plantings that we had without the plastic there during that very hot weather. And again, I think just observationally, when I look at some of my other orchards, like, again, having that cover crop and the vegetation in the orchard has been a huge benefit in these hot days for helping just cool the area, retain some soil moisture. But again, that the plastic, we tried to put some probes in. We had some technology malfunctions. It was one of those like perfect storm. You're already up to your eyeballs in replant and can't seem to collect the data that we'd intended or hoped to. But I do, I think Dr. Shackel, your comments were really interesting to me. I've also, wondered about the wisdom or the logic like we've, employed here around sort of filling the soil to soil capacity in the spring. Like, what is the impact on root systems? We're filling the soil with really cold water in our situation, right? Mountain water from our irrigation districts. That was something else under the plastic was, the soils warmed up quicker and stayed warmer in the spring. And I think we had the benefit of some additional root growth as well. But, I wondered about that logic. We've talked a lot in these drought years about, how can we reach field capacity to start the season off on a good foot, but is that the right approach, or is that maybe something that we think is doing the right thing?
Yep, that's a good question. I mean, I'm a little bit of a broken record in terms of the California growers. I think that the only way to really figure this out is to measure the plant, is to find out kind of what status the plant is at. And the go-to measurement that I use is the pressure chamber with stem water potential. I'm sure Alan and other folks know a lot about that. What I was in terms of this meeting, I wasn't sure whether well, I thought I was supposed to talk about plant-based approaches to irrigation, and there are a lot of them. I wasn't going to talk about all of them, but it also sounds like there may not be general agreement that plant-based measures are, let's say, the gold standard for irrigation management for you guys. Is that fair to say or not?
For me, no. For me, no, kind of. Like if you had drawn data or any artificial intelligence or anything data, could be nice to see it from that point of view. Also, how the stress areas, like what I imagine the sensing can show us where we had the most driest spots in large acreage.
Good. I actually have.
I don't know if that could be done.
Yeah, I actually have some data about comparing the plant-based measurements to the drone measurements that you might be interested in. If I get to that in my talk, which I should. Should I just go ahead with what I was going to talk about?
Yes, go ahead.
Well, okay. I mean, I really love these questions. So, but maybe if we get through it.
Yeah, we have time. It's 7:38. At least we have we have time.
We almost have a full hour here. So
yes, no.
Okay. Well, no, I won't take that much.
No, the opportunity to talk like this.
Okay, hang on a second. Hide this. Okay, hide that. All right, let's see now. So hopefully I can still use my page up and page down. So when it comes to plant-based measurements, I would say at the moment, there's a lot of people assuming that all we need is a Mr. Spock with some kind of tricorder, and I call that, the holy grail of plant-based measurements. And I just want to mention that recently there's been a lot of activity in this space, okay? And with big companies. So here you got Suzuki. Can you see my pointer all right?
Yes.
Okay, here you can see Suzuki selling, oh, wait a minute, I skipped one. This something, Thule Vision, okay? I don't know if you've heard about this, but they kind of reckon using AI that you can drive up and down your grape rows or whatever orchard and get a value for water potential or plant stress just from that. Toro is using a sap flow meter. I haven't tried the Thule Vision, but I have tried these sap flow meters, and they're not reliable in my opinion. There's another one from Yara that's using, actually, it's kind of an old now idea from Zimmerman called the ZimPro. Now, I've used a lot of these, and I don't, and also dendrometers. One of the issues with dendrometers is that fruit dendrometers have been already used for a long time, But my experience with those is that you really can't know when you see the fruit growing or not growing, whether it's water that's limiting or something else that's limiting. I'd be interested if people have had experience and use fruit dendrometers for controlling irrigation, but I think they're also limited as well as a trunk dendrometer. I would say that measuring stem water potential has kind of gotten to be the gold standard in California, maybe other places, using a pressure bomb, but there are other methods that you can use to measure it. In situ psychrometers are very difficult even for researchers to use. And there's new devices. This one called Saturas measures stem water potential, but my understanding is this company's no longer in business because that sensor didn't work out very well. But there is one sensor that measures stem water potential called FluoroPulse. It's a microtensiometer, and that works. So for instance, this is an example of tree by tree, one measurement in time over a long season from a whole bunch of trees. Actually, we only measured them a few times, of a very good relationship, almost 1-to-1, not quite, but very close, with the pressure chamber. And so we had this experiment. Now, this is not going to be applicable, I suspect, to apples or any fruit like that. We had an experiment in almonds where we had control trees and moderate stress trees and severe stress trees in 3 blocks, because in almond, it looks like they can tolerate some stress. They actually benefit from some stress. And what I did last year was say, if these sensors are that reliable, I am going to try to actually control the irrigation for each of these little plots, not the controls, but all the other ones, with a microtensiometer, program a data logger to make the measurement actually it measures 24/7 basically, and it turns on the water when the trees get to a certain threshold that I've decided based on whether I want it severely stressed or moderately stressed. And here is the results of last year's test. So these curves are what the microtensiometer measures. So it would be stem water potential at midday. Our target for this plot was about 18 bars midday, and these trees kind of were hovering around there, but tended to get below 20 a little bit. But I left the set points the way I originally let them, originally determine them. And here's an example where I made a mistake and I irrigated, this is about a ½ an inch of water, and then the trees recovered. But then I let the system decide when to start irrigating, and it just waited until the trees got into the zone, and it just every day applied, you can see, relatively small amounts of water, 16/100ths of an inch or 7/100ths of an inch. That was in the moderate stress. This is one plot in the moderate stress treatment, one tree, the center tree that's being monitored, and then moderate stress plot. And then in the severe stress, where we wanted to let them get into the 25 range, which is not life-threatening for almonds, but definitely stressed. This system didn't even start until basically, I think actually this first irrigation here was a fertigation, didn't even start until the early July. And in California, that's a long time to wait to start, but it was a wet winter. And finally, these trees got into the zone, and this system just put on even less water, but on a daily basis, just pretty much kept them, in the zone that we hypothesized would be good. Now, the yield this year was very low, and we don't expect the yields to be affected very much at the first year because it's more of a carryover effect in almonds. But you can basically see this day, for instance, when the water potential was didn't dip down so much, was kind of a cloudy day. So then the next day, the irrigation didn't irrigate much. And then it did dip down. And so the irrigation just responded, and it kind of got back to what we wanted. So the point with this is that this is a very kind of a proof of concept idea that you can actually use the plant to irrigate itself. These are the weekly values just to show you that in almond and other crops, we have this baseline value, which is a fully irrigated value, that even in the controls, we don't irrigate to full irrigation in mature trees because they would just grow too much vegetatively. And we also have periods of time when we have to cut the water off for harvest, and periods of time even before harvest where we cut the water off for what's called hull split. But you know, you can see that the severe stress treatment took a long time to get severe stress and was actually even wetter than the moderate stress treatment for a while and we were just waiting to irrigate. So this was just some, you know, the variability in trees, but they pretty much ranked out with the severe having lower water potentials, than the moderate and the control having the best, basically, except during harvest when everybody got stressed. And what surprised me was the huge difference in amounts of water that we used. So this is the cumulative amount of water, and the controls based on ET, depending on whose crop coefficients you use, the water use should have been about 42 inches. We had, you know, you can see here, we had some 3 inches, a couple of inches in February, March. It was a fairly wet winter and spring. And as a result, you know, we just didn't irrigate much, even in the controls. But a big difference in amounts of water. And we're so far this year, they bloomed, even the severe stress trees bloomed okay, and they all seem to have a high crop load, but we'll see sooner or later there's probably going to be some effects of the severe stress. But I was kind of surprised that we got as small effect as we did. Here's an example of flyover in this particular same spot, actually. And you see that they flew on 3 different days. And these are the canopy temperatures. And here's, I think, just an artifact. There's no reason for this part of the field. There was no evidence that the trees were any different. And when we used the pressure chamber, at this time in the year, they were all very wet at the baseline, basically. This next time, you see kind of a gradient from one side of another in this plot. And I'll show in a minute, there was no evidence of this gradient in the pressure, in the fluoropulse numbers, because we had trees scattered around here with fluoropulse values. And finally, on this last day, you can kind of see where some of the drier plots were. So I've got a map that kind of shows that digitally. And for these flyovers, they actually gave us values for individual trees that we could relate to the values of a specific tree, or actually I used a 3-tree average for the drone numbers, or what's called the crop water stress index for those 3 trees in the middle tree water potential. And if you do the correlations, what you get is this. The first reading, we didn't have the water potentials from the fluoropulse, but the second reading in May, sorry, there was no correlation between what the water potential was and what the crop water stress index was. But finally in July, we get a pretty good relation. But so I think that's been this experience with most folks with these flyover drones or satellites, is that they usually don't indicate the initiation of stress. But once trees get really stressed, then they can pick it up. So I guess my bottom line is I think we using the plant, we can get a good idea about how stressed it is. And in the ultimate guess, the final frontier is we should be able to let the plants irrigate themselves. But I would say that in order to do this, you gotta have an irrigation system that can respond to either individual plants or groups of plants. I did it in, partial rows, but all this technology is not going to solve the problem of spatial variability and how to irrigate. It's just going to show you where maybe you need to maybe split the irrigation system up or do something else, add drippers, take away drippers, to try to solve these problems. That's where the plant-based measurements have been very instructive, at least around here.
So Ken, I have a couple of questions based on your presentation. So the first one is on more than a question. This one will be to just make sure that I understood well. So the ETC, which some growers might be using, and we don't know to what extent, is measuring what is the ideal or the hypothetical demand, but not necessarily what is needed for that specific site based on the conditions that are there prior to start that irrigation. So let's say you have high moisture in your soil or any other limiting factor, and then you're still using an ETC that is more a calculation of what it should be demanded by that crop, but not necessarily demanded by that crop. Is that correct? Is that what you...
So that is a complicated question, and I have a whole slide set to talk about that. However, my first question to you is, when you say ETC, do you mean the actual measured ETC or a calculated ETC using a crop coefficient?
Yes, the calculated one, which is what I will assume is the one that the growers use based on the weather data collected from their orchards or a nearby weather station.
Well, where do the crop coefficients come from? I mean, the
theory.
The reference, what reference? So you use reference ET measurement, right? Or do the growers, there is the Thule system, and there's other systems that say they're measuring ETC. That's why I asked this question. That if they're using a KC, then they're not measuring ETC. They're getting a measurement of, or an estimate of, reference ET, and using the KC to turn that into what they think the orchard is demanding. Is that correct?
Yes, correct.
Well, so where did the crop coefficients come from?
A theory.
Sorry?
The theory, a
well,
theory.
No, crop coefficients are supposed to be determined, right? They don't, unless you guys have some theory that you can calculate. Well, Alan, maybe you've got a model that
maybe
they use
Alan,
for the
or
crop
maybe I see here that maybe Maria Isabel or can help me. Maybe I'm misunderstanding the comment, but what I believe is that we use a coefficient that is standard for apples, let's say. It's not something that we are measuring on site. And I'm not talking about me. I'm not using that technology. I'm just trying to clarify the point.
But I see, so that is the key thing, like to explain that, because for transpiration or evapotranspiration, we have been using the grasses kind of to see that coefficient of transpiration of the grass. And when you compare the physiology of the apple tree and the canopy and everything is completely different. So we need to try to understand how the plant, again, the plant, whatever is that plant need to be understood. We need to know how that plant is feeling at the end. You know, in the case of the cherry, for example, I'm gonna make it the other way around. Like for our cherry to grow here, cherry, but if we don't irrigate and we don't have enough water, rain, perhaps those plants are gonna be under drought, and perhaps flower initiation can suffer, and we can lose the flowers next season. So we really need to know, you know, we have water, but perhaps not enough for sweet cherry production. I don't know. to compete with Washington. I don't know. You know, it's an opportunity. It's looking for that opportunity for growers who had that capability also to be cherry growers. You know, okay, this, I don't.
Maria and Alan, you both look like you want to say something. Did you want to respond to Bernadita's question and to Dr. Shackle's comments here?
Mm-hmm. Bunch of apple growers talking about irrigation.
I'm gonna mute. And I can go ahead and explain a little bit about Oregon. In general, the crop coefficients that we have associated with the agreement stations, which is the agreement stations are weather stations. It's a network that is available for growers or to the public. And the crop coefficients come either from previous literature, previous research, and this research could be from very accurate methods like lysimeters, that is very rare because they're extremely expensive to install, to, you know, like other nowadays more refined methods also, like using satellite and remote sensing. But we are in the big need of refining crop coefficients that are available to the public, specifically for different varieties, different regions, and it's not perfect. So it's like a ballpark, if you will, like different crop coefficients. So when you said, Ken, about the crop coefficients should be determined, I completely agree, and I would love to know maybe potential ways in which we can adopt in Oregon for largely extending methods to determine crop coefficients and help growers across the state.
I'm just going to mention this. We had a meeting here at Davis last quarter and discussed crop coefficients in almonds specifically. And we had a lot of crop coefficient experts. And because there's a number of researchers here at Davis using eddy covariance towers to measure ET directly and comparing it to other methods. And the bottom line is that people are starting to doubt that they really know what the crop coefficients are or should be. And the reason why is because the way crop coefficients were initially defined was an unstressed crop, full water use, the full potential water use. And there's been the belief, strong belief, I would say, in the micrometeorology field for a good 20 years that the maximum crop water use is represented by what's called the energy limited value, that you only have so much sun, so much wind, so much humidity, and that nothing could use more than about 30% or 25% more than what grass uses under that condition, if you're using grass, for instance, as the reference crop. We have lysimeter data on almonds that shows that the crop coefficients can go up to 1.4. And we have crop coefficients measured using eddy covariance towers that can be anywhere from 0.8 up to 1.2. And I think actually the original idea of a crop coefficient was just to get people in the ballpark. And it wasn't really designed for every day you look at the, ETO or reference ET and get your crop coefficient, and that tells you how much they use that day. I think that's, even though that's kind of the way things have been talked about for many, many, many years, I think that's probably misleading. So sorry to put a negative spin on it there, but as we look more into crop coefficients, I think the more we study and the less we think we understand them.
Alan, would you agree with that? It looked like you were going to add to that conversation.
You're muted.
there still.
You're muted, Al.
Sorry. Got a barky dog. In any case, Ken is right. I think you always have to understand what the assumption is behind these things. And as he said, the assumption is that this is a healthy, well-watered plant under no stress. But there's other things that can cause differences in water use. Obviously, if you have nutritional deficiencies or foliar diseases, things like that can reduce the water use. I know in several cases there have been studies that showed if you have a heavier crop, the plant will use a lot more water than if you have a light crop. And so we studied this a lot in apple. And one additional issue for us in more humid zones is that there was a study by Annandale and Stockel at Washington State about 30 years ago, where they just did a theoretical study, and they said if you have different humidities, the crop coefficients should not be the same. And so we started looking into it and realized that, as Mario pointed out, you have a big, rough canopy that's well exposed to the air. It's mixing and everything. And then you're comparing that to water use of the model ETO is for a grass or alfalfa, something really low and continuous canopy. And what happens is that that really low canopy gets a little layer of still air above it, a boundary layer. And that boundary layer tends to trap the humidity that's given off by the crop. And so it's almost like putting the plants in a box. If the stomates open up and it gives off more water, it becomes more humid, which cancels out that demand for water. So what happens is if you look at and I did this here with our weather, if you look at the actual ETO estimate versus radiation only, it has about like 92, 93% of all the variations just due to radiation. But here we can have a sunny day that's very hot, very dry, and then the weather front will come through from Canada, and all of a sudden it'll be as it was today. It was only 68 degrees, 20 degrees Celsius high, but full sun. And ETO would say both those days would be the same. But we know from apple physiology that the stomates work in an unusual way such that we actually decided by both in theory and also measured. We used sap flow gauges where we could measure the flow through the plant, although I don't trust them by themselves. We actually enclosed the trees in chambers and measured their actual water use to calibrate the gauge, and then removed it and let the gauges go through the summer. And we found that the crop coefficient from day to day here compared to ETO could be as low as 0.4 or 40% as much as the grass, or it could be 110% as much as the grass. And it's when you have cool, humid days that are sunny, then the tree uses much less water than the ETO crop coefficient would suggest. So, but we realized what we could do is actually make an apple-specific ET model using the same Penman-Monteith basic physics model, but putting in the apple responses and the fact that the apples don't have that boundary layer, and adjusting the model for apples. And that came out with a very nice correlation to our measured studies. So we have that online with the NUA weather network that's in most of the more humid eastern, north central areas. And So I know some growers, I'm not sure exactly how many are using that. At least it's better. I think it's better than taking a crop coefficient from California or Washington. But
Alan, and maybe just to follow
Evans,
up on, go ahead.
I was just, Bernadette, I think Bob Evans did some direct measurements, if I'm not mistaken, for Washington on apple crop coefficients.
Maybe before my time, but I see Paul is shaking his head, so probably he did. And I just wanted to follow up on, so my initial question about the ETC and crop coefficient, and again, now that you mentioned this new crop coefficient, Alan, my biggest question is related to your comment, Ken, about the dendrometers of not indicating when there's other limiting factors. So when we have a crop coefficient or when we have a plant-based sensor, how can we know, how can we tell if there's no other limiting factors that are limiting that water demand or water stress or stem water potential stress? That would be, I believe that is a challenge that we had here in the Smart Orchard project, and I can share some examples, but just to go back to the question, maybe you understand what I'm trying to say.
For me, the value of using, let's say, stem water potential is because that's specifically related to water stress. So if the tree is stressed, then you would assume that there's a problem. And if you irrigate it and it stays stressed, then you have other alternatives, right? That the root system is damaged or something else is happening, or you didn't irrigate it enough. I mean, so that's in most cases, at least where I've, in most cases of what I've seen, the trees respond to irrigation. Actually, that's the reason why we have the baseline, because if the tree is at the baseline or near the baseline, even if the soil looks dry, you know that you don't really need to irrigate it. And so that prevents you from over irrigating. But in cases where there's stress and it looks like the soil is wet, then you have to look for what else is limiting. Is that what you're talking about? Limiting water uptake that's not irrigation related?
Right, precisely. And I share that because I was leading one of the Smart Orchard projects last year where we evaluated, and I have my colleague and he's the PI of the project, Lab Code, where we compare several different tools for evaluating plant stress and also soil mapping technology and drone mapping technology and so on. So when in this particular case, we have two areas where the trees were showing stress, water stress, which actually Victor shared in the last session, where two areas were showing stress. But the reason for that stress was opposite for both cases. In one was a very sandy soil where the water wouldn't stay, and actually because it's in a slope, the water will move out of that area very fast, and it will accumulate in this other lower portion of the valley and then when you look at the root system, there were no roots in that area. The trees were very stressed, but for opposite reasons.
Yeah.
So
yeah, that's a perfect example of where you need to, where the plant-based measurements will help you identify the problem, but then you may need the soil measurements or something else to figure out the source of the problem. I can mention that one of our previous graduate students here went back home to Chile. His family is they have an irrigation company, Andres Olivos. I don't know if you know the Olivos family. Anyway, they had prune orchards, and they were irrigating them all the same. But he used a pressure chamber to find out that, I mean, these were all sections of the same prune orchard, but they had made different irrigation sets. Some were on a slope, some were in the valley, some were, different. And the amount of water that was needed in these different areas was anywhere from almost 100% ET to almost nothing in some of those areas that were getting water from drainage from other areas. It was a huge difference in the right amount of water to give the trees to get them in the, let's say, the zone of water potential that they should be, so that they have the best yield and the best dry away and all the things that are important in prunes, which is grown for drying. So it's not the same as a fresh product. But what surprised me was the size of the differences. It was like different worlds.
Precisely. In this case, it was only 16 acre, and the differences were very large and probably similar to what Mario was sharing about that soil variability. Even though we have areas that are not very variable, we still have a lot of variability here in Washington too.
Yep.
Thank you.
Ken, Kevin Dodds has a question for you in the chat, and he's turned his camera on, and we'll ask you directly so you can have a conversation with him.
Great.
And Paul, I see your hands up. I will return to you.
Great. Hi, Ken. Hi, everybody. Thanks for your presentation. Really enjoyed that. I've worked with the New South Wales government in Australia as an extension person, mainly with apples. So that's my interest and why I logged in. A colleague did mention FloraPulse to me a while ago, but I hadn't really looked into it. It does look promising. I'm interested whether you, in your study, whether you looked at yield impacts of the different treatments and the pulsing irrigation that you used with FloraPulse.
So the data that I showed was in almond, and it was from last year, which was the first year we imposed the treatments. So there was no differences in yield from that first year, but it wouldn't be expected because in almonds, the crop is set early in the season, and maybe you'll see a difference in kernel size, a small difference in kernel size from the different levels of stress. But another problem we had was it was a very low crop year. In fact, that experiment involved thinning of some trees and not of others. And we didn't even see a thinning effect because the crop was so low. This year will be the first year where we have a following year, a yield year following that stress level. And based on the bloom, it didn't look like there was any problem. But I don't know what the set was. This year we're tracking that optically, and we still have a lot of data to do. So we don't know about we don't know about what those levels of stress would cause. I'm expecting that the severe level of stress should at least reduce yield by a half, let's say. But nobody, as near as I know, no one has ever regulated stress to that level of daily irrigation to kind of keep it in that same zone. Usually people will, irrigate less or stop irrigating or something. And so I think it's a potentially whole new area of research to find out how much water plants need, to maintain yields, but not use full ET. So I guess the short answer is we don't know.
No, that's all right. It sounds like it's a little bit early for your studies, but I wonder if you know of anybody that's doing work specifically with apples in the States that's with FloraPulse that would be a good contact.
No. I mean, you should talk to the FloraPulse folks. They would know if anybody's using them. Andres Olivos in Chile has been using them. I don't know if he's used them in apples or not. I'm sure that, well, there's been people, do you use stem water potential in apples with a pressure chamber?
Not commonly. It'd be used in research here, but not commercially.
Okay, that, you know, there, anybody that you can extrapolate from anything that the pressure chamber measures, if they measure stem water potential, to what the fluoropulse should do, because they measure the same thing. So I don't think in a way you need to worry about whether somebody's using fluoropulse. It would be to find somebody that uses the pressure chamber to measure stem water potential and see what they get.
Excellent.
So,
thank you.
Kevin, before we move on to Paul that has the hand up, in Washington, we have done some work with the fluoropulse, and I see Victor is there. Victor was working with leaf acids in apples with fluoropulse, but also we are doing that again for this Smart Orchard project. So if you want more information, we still don't have the full results, but we're gonna be measuring for 3 years fluoropulse and many other sensors in this orchard. So happy to connect with you later.
Yeah, excellent. Thanks. And I have met Lee when he's been out to Australia, so I kind of have contact with him too. So excellent. Thank you.
Yeah, I just note that Victor had done a lot with Lee Calsitz at Washington State, and also Terrence Robinson here, and with Luis Gonzalez Nieto looked at the water potential with different stress levels and monitoring fruit growth and development with the fruit dendrometers to try to identify at what point you began to have detrimental effects on the. So there is some research work, and some of our growers, I don't know that they're.
So the grower are, I don't know if Kevin or David Binner is here from New York, but they have like 8 sensors or 7 sensor microtensiometers. They are in Niagara County, next to Niagara Falls, that is the driest spot of the Lake Ontario fruit region. So they really need to irrigate in that piece of the lake next to Niagara. The apple acreage, the big apple acreage in another county, in Wayne County, is a clay. It's a completely different soil. So completely different. And we got a lot, we don't have a lot of precipitation, but we have precipitation. And we are installing still 2 or 3 or 4 microtensiometers this season, Alan. I know I'm fully involved in the research, but it's at least one in Champlain, one in Hudson, and one in Western New York, and definitely in Geneva also. So we are going to be collecting data from this year. And one thing I want to share for us, like we didn't know this. Later we learned that we lost a lot of return bloom in Honeycrisp. That is one of the most important apple cultivar that we have in the US, and also in Ida Red. That is one of very important cultivar for processing to make apple sauce. And it's because Honeycrisp was stressed out, that plant early in the spring, because it was a dry summer. So we didn't have enough snow, we didn't have rains, and Honeycrisp was dry. You know, like flower bud initiation start very, very early in Honeycrisp, like even 15, 20 days, sometimes 30 days after full bloom. So we really need to have that plant nice. So we didn't know how to irrigate Honeycrisp in our conditions. So from the last 2 years, our best growers are starting to irrigate or make sure that we have the right soil moisture early in the season. That from before, for me, well, okay, like if we're gonna lose a month trying to plant an orchard in the spring here in New York, hey, why we don't do it in the fall? Because it's easier, and we start planting a lot more in the fall also, because in the past, when I got here, we had so much snow and rains that you can lose, if you wait to plant your orchard, you can lose 3 weeks, 4 weeks, 5 weeks, because it's too wet. You cannot plant those trees. So it was amazing, but now it's the opposite.
Okay, I'm going to jump in here because we have 3 people with comments trying to get in from the conversation here. Paul's had his hand up long enough. Paul, can I ask you if you just hold on for a second, because Victor suddenly tossed his hand up real fast. Victor, were you wanting to address something specific that was part of that last conversation, or can we circle back to you in a minute after Paul and the other question is answered?
Oh, it was just to say that the experience with the Honeycrisp apples in Washington was pretty good. They were really responsive also because the Honeycrisp apples were grafted on M9, which is pretty or a rootstock that is not that explorative. So the response of the sensor was really fast, as well as the response to the irrigation treatment that the apples had. So we were able to identify the stress, yeah, pretty fast, or faster than with other sensors. So yeah, the response was pretty good, at least under the conditions in Washington State.
Victor, what sensor are you discussing?
The fluoropods.
Ah, okay.
Yeah.
Okay, Paul, you've been waiting long enough, and then we do have a question from Gregory, and I'm coming up here.
Yeah, I just wanted to kind of address Dr. Shackel's he asked a question before he finished his presentation, which is like, you guys don't seem to like the plant-based sensors for apples. Like, why not, kind of thing. And I wouldn't say that we don't like them. I just think I think it's great. And it's like, it's definitely the frontier technology for irrigation. It's just, I think there's like several questions that remain to be answered about using this technology practically, which are like, this is like a point source. It's like one data point in an orchard, right? It's one tree that you're getting data from. So there's so much variability in crop load, plant health, everything in the field. So it's like we need recommendations about like how many sensors do you need per acre, like to get a reasonable sense of what's going on. Like how do these work in different varieties of apple, right? And trying to achieve specific goals, like what levels of plant stress do you need, water stress do you need on different varieties, right? And so I think it's just those sort of things really need to be ironed out before it'd be practical to try to use this in a commercial setting to grow apples. So I wouldn't say it's a bad idea. It's a great idea. It's just like there's still lots of research, I think, needed to make it practical. And maybe you could comment on some of those concerns.
Yeah,
just a second, sir. I'd like to add a question to that, and Mario kind of raised it as well. To add on to this, what do you project the costs of this for a grower, and how much, what kind of return on their investment would they need in order to make that back? If you could do both of those at the same time, that'd be great.
Sure. Somebody else had a question?
Yeah, there's one more. It's about surfactants mixing into the water, so it's kind of off this.
Okay. So I think you put your finger on a couple of very important points. One is variability, right? You got different varieties, different crop loads, different soils, all that. If you have an irrigation set, you have to make one decision for that irrigation set. So if you can find the average tree, then I would say, and I know prune growers that have done this in California, they find the average tree and they just measure that tree and they irrigate to that tree. And if it's a relatively uniform, even if it's not uniform, they still have to make one decision for that spot. So, if you irrigate to the weakest tree, you're probably going to be over irrigating. And if you irrigate to the strongest tree, you're probably going to be under irrigating the weakest areas. But so you have to make that compromise. And one good thing about using the pressure chamber as opposed to fluoropulse is that you can go around and check different trees if you're concerned, just see, oh, this is a weak area. Well, that's how much, stress, how much difference we're getting. Actually, we're starting to do that a little bit in walnuts this year, trying to find weak areas and strong areas and put fluoropulse in both of them to find out whether the weak areas are weak because they're always running low on water at the end of the irrigation cycle, and so they just need to maybe increase the frequency, like Paul suggested, or if it's something else. So in terms of the spatial variability, I know that that there's a lot of research talking about satellite imagery to look for spatial variability and all these other drone approaches for spatial variability. I think growers already have a pretty good idea about how spatially variable their orchards are. And they're probably in the best position to check and then adjust their judgment about where they should be in terms of what trees they should use as the ones that call the shots for the rest of the plot. Generally, what we find is if you monitor 10 trees in an acre of land, you'll find that they all move in parallel. And so you just find the one in the middle of the pack if that's the typical one and just use that. So I think a lot of the growers that just use the pressure chamber, this is not for the fluoropulse, that just use the pressure chamber, sort of do a little bit of a survey, and it doesn't need to be a big one. And they kind of figure out which tree would be a good reference site for their irrigation. That probably needs to be done if you're going to put a fluoropulse in anyway, because you don't want to put the fluoropulse on, any old tree. Now, in terms of the cost of both of these approaches, everything depends on how much benefit improved irrigation management is going to make. And in terms of walnuts, one of our extension specialists, Bruce Lampinen, did a study of the growth of the trees in the first, I think, 5 years and their different levels of water stress. And there was a very clear relation between growth and water stress, more water stress, less growth. But he also monitored trees that were over irrigated and they got less growth. So there's kind of an optimum. He found an optimum. And if you're off of that optimum, he calculated that the amount of yield the yield return, even in the first year when they are yielding the first crop, was more than enough to pay for a pressure chamber, for instance. So I think that there's been a lot of doubt and to some extent resistance, and I understand this because there's so many gadgets that so many companies have by trying to sell so many growers that everybody is gun shy about trying to, just getting a new gadget. But I have seen the pressure chamber to be kind of the most valuable tool because you can move it around. And it's not if somebody's trained properly on it, they'll get good reproducible data. It's not rocket science how to use it, basically. But there are some misunderstandings about how to use the pressure chamber, like not bagging the leaves or whatever, that can mess you up. So I'm happy to train anybody that's interested in learning, and we've got some videos too. When it's used correctly, it's a cost-effective tool. Now, the fluoropulse, that's an interesting question because you're spending, I guess, a couple of $1,000 to get one tree monitored 24/7. I don't know, Alan, if that about right? 1,800 or something?
I think it's 1,500.
Okay, so that gives what that gives you, whether that additional value of having 24/7 data is worth that investment, that's a whole nother question. But I suspect that once you realize what those trees are experiencing and what you realize, like when you start irrigating in the spring or when you wait after a rain, if there's stress going on that you didn't realize, or you can wait a lot longer, then that level of detail, which you could get if you just use the pressure bomb every day, that level of detail might be very, very economically important for things like fruit sizing, maybe, flower differentiation at the right time or wrong, if you miss that window. So again, I'm a broken record. I think the more you understand about the level of water stress in the plant, the better able you are to manage it. So, but I think that the numbers are penciling out to show that at least the pressure chamber is a very good investment.
Okay. Thank you. I appreciate that. There was a very thorough answer to that. I really do appreciate that. I'm going to jump real quick. Mario asked a whole bunch of questions that maybe we'll come back to since it's already 8:30. But I'd like to get Gregory Hines' question asked here. And Lisa Wambold, if you're still on the call or on the conference here, maybe you'd like to discuss a little bit about your response to this. So I'm just going to read it. Gregory says, has anyone tried surfactant mixed into their water to reduce compaction by getting water into micropores of the soil and move water through the soil profile? Does anybody want to comment on that?
I'm not going to touch that one.
Lisa's response to it was that uptake soil adjuvant from Paste Solutions is registered for this, but PMRA, Health Canada, here in Canada, just removed food crops from the label. So I don't know. Does anybody want to have anything to contribute to that question? Well, you have to stump her.
I will just wonder what is the goal of that application? What is the problem that they are trying to solve with that application?
Yeah, Gregory, if you're still on, I'm curious if you wanted to elaborate a little bit on that. I'll check the list here.
I've used it.
You have?
It doesn't last very long. It can like increase the penetration rate of water. Like if you have crusted soils, it can help with that, but it doesn't last very long. It's not like from my experience, it wasn't like a night and day sort of thing.
I think it's also important to understand what is the problem. And that's why I asked that question, because if the problem of penetration of the water relates to excessive sodium in the soil, there are other more effective solutions to that, which is probably using gypsum for our soils here. So you need to add some calcium to the soil. If the reason is other than that, then that's why I wonder what they're trying to solve with the application.
He did respond. The response is lessen compaction and move water through the profile to reduce watering.
So again, I think it depends on the compaction. What is the reason for that compaction? If the compaction is because you have high sodium in the soil, application of gypsum could be a good tool and a cheaper tool and very effective. But if the compaction is due to other reasons like driving tractor and stuff like that, or lack of organic matter, then adding organic matter will be another option too.
All right, thank you, both Bernadine and Paul, for responding to that. So it is 8:30. Technically, our virtual meetup ends at 8:30, but Mario just asked a couple dissertations worth of questions in the chat here, and so I'm going to let him just open up his mic and unload.
Yes.
We'll keep the conversation going as long as you want. Those of you who have to go, thank you for being here. But Mario, have at it.
Yeah, is Molly here still?
No, she had to leave.
Oh, she left. Oh yeah, because I didn't know how the thing there with the cover crop. They had to irrigate the cover crop between the row. They had to water that stuff to keep it alive. Or
Yes,
how they do it?
Yeah, in the area that Molly works, which is north of Washington, like Okanogan area, and here in Washington, the only way that we can have a cover crop is to have a sprinkler irrigation. So we need that irrigation. That's in most cases why the growers have sprinklers and drip together so they can water the cover crop.
Lindsay, did you want to comment on that? Because I see you turned your camera on.
Oh yeah. No, I mean, it's very similar to Washington State. So same deal. A lot of growers, especially vineyards now, are getting more interested in cover cropping between rows. kind of Lisa Womble did a great job, and so did Molly, of describing the benefits of those. But it's not uncommon to see micro sprinklers in addition to drip on dual systems in our vineyards and orchards around here. So we're kind of moving away from those overhead systems and then into the dual systems where you would normally just see one of them.
Paul.
Yeah, Paul, I see your hand is up. It looks like you
muted.
want to say something too. You're muted.
So following up on like what Lindsay just said. So we have all these dual systems, and so like, I don't know if you could imagine how like the FloraPulse might be able to divide the water between sprinkler and drip, because like this is controlling just a single source of water, whereas we have multiple water application methods. So
the system that the system that I built was a very simple system, right? It's, one valve for half a row of trees, and the valve, just made one irrigation a day, and it decided based on what the previous day's stress was. But I would say that there's no reason why engineers couldn't, figure out AI or whatever to sort of read what the water potential was, and decide about which sprinklers should go on or off. That's where I think we really need research, because right now I don't know whether Alan can do this, but I could not predict what level of stress would be a net benefit or a net detriment, depending on when in the year, what crop, what variety, any of those things, right? Even on the crops where we have almonds and walnuts, where we've been doing one variety and we've done some research. We're still this is, to me, we're still in the dark ages about knowing what the optimum trajectory is through the season for that tree, to maximize yield, minimize excessive vegetative growth, maintain bloom, all of those things. We can guess, but there's been no research to directly related to that question. While I got the floor, Daniel, I haven't been looking at the chat, except I glanced at it, and there's some comments in there for me. You can give people my email, and they can contact me if they have questions, if that's okay with everybody.
Oh, yeah, I don't think any of us would object to sharing email. The point of this is to disseminate as much information as widely as possible.
Yeah.
So
Yeah.
my email's in the chat there. Feel free to email me, and I will hook you up with anybody that's participated in this. Also, hosts, if you want to just toss your email in there, I see Emily just did that. Go ahead and toss your email into the chat too if you want to do that now. But otherwise, yeah, if you're interested in more information, please reach out to myself or Mario, Bernadita, Emily, Lindsay, Christy, the whole gang. So yeah, and also please take the survey if you would, because the survey asks questions that would be useful to us for next year's planning, and we want to keep this going. It's a good discussion.
Yes. No,
Alan, sorry, Mario.
Yes.
Before we close, Alan, I think you were going to say something.
Well, I was just make a quick comment on Ken was talking about. We don't have optimum regime water stress regimes for all the different crops. Probably the one that has the most is the red wine grapes, where they're trying to get maximum quality, and it does require some minimum crop. So values of maintaining something around 11 or 12 bars stem potential during good part of the season is pretty well been worked out as a general target. The other thing that unfortunately we don't really have the time, but Victor had some very interesting results of actually the interaction between water status and these heat spells have. And Victor and Lee had some data where they had the pluripulse looking at the trees and then irrigating, say, in the morning of the super hot days. I don't know if it may be too late, but there's some very interesting results there. I don't know, Victor, if you've.
Yeah, I think that because we were working with apples and those really dwarfing rootstocks, the response of the tree was super fast, and we were able to identify both heat stress and water stress. So yeah, still working on the results, but yeah, it's a great work, and I guess that Lee is also working on that. So yeah, hopefully a lot of results that will be published in the near future.
Nice.
So maybe just to follow up, Victor, I know we ran out of time, but I see that Ken's still here and Alan's still here, so we can continue the conversation. I have a question related to that carryover effect. Ken, you mentioned that carryover effect from one day to the other, and I wonder what happened when you have a carryover effect from one season to the other. Thinking about what we learned with Kirti and Denise at the beginning of this session, where we are expecting more heat spells here in Washington and everywhere, pretty much in California, where we need to manage the heat. And here in Washington, we do it by overhead cooling or netting. How can we use these tools? And also, what do you think will be a management practice of those two questions? How can we use these tools with this condition where we have to overhead cool or have netting, which will affect this probably the stress of the plant in some way? And the second question will be, what can we do if we expect high temperatures and we have no or not enough water availability, or our system is not capable to supply that demand? What other strategies we could use for that?
So for the answer to the second question is to go to church and pray, right? Okay. I mean,
I was thinking of pruning the trees completely.
Well, okay. So I did an experiment in almonds specifically to test, and this was before Floripulse, specifically to test the strategy of a drought year. For instance, if you knew this year you weren't going to get water, or you were only going to get very small amounts of water, what you should do, the best thing to help the tree survive. Okay. We did the experiment on a very shallow soil. We did the experiment on mature trees and almond trees that were grown on single line drip for their entire life, and they were mature, I don't know, 20 years or 15 years. All of those things should have meant that if we didn't irrigate them, they would die. We didn't kill any trees by not irrigating them, okay? And it turned out that these trees, even though their active root zone was only maybe a half a meter, they had roots down to 3 meters into soil that the irrigator would not even pay any attention to, because it's a gravel soil on top of clay soil. And everyone talks about, oh, the root systems are very restricted and we're growing it with just a single line drip, so they must be only around the dripper. And that's true. Those roots are there, but there's other roots. And when the plant is under stress, it reduces its water use. And it turned out that even small amounts of water given every day could, even though they didn't add up to much at the end of the season, they were a benefit. But in addition, the reason I mention this is because we also tried pruning, taking the tree off at 50%, and we tried spraying kaolin on the trees and spraying and pruning, all of these things. Nothing made a difference, okay? None of those ideas that people thought would help the trees did any good to the tree. They still had the same level of water stress, but this was a situation where you know, you stop irrigate or you don't irrigate in the beginning of the season. And if you've had some winter rains and if there's stored soil moisture, what the trees do is they just gradually get dry and they gradually defoliate. And we actually had a few trees, one tree that got beyond the range of the pressure chamber that we were using. It got to 63 bars. And by the next week, it was completely defoliated. But and the next year, that tree had not one flower on it. So it had no yield the next year. But it did have shoots. And after one more year of just normal irrigation, it came almost all the way back to normal yield. So my point here is that the rule of thumb we got from that experiment was that the yield effect in the first year the reduction in yield of the first year of a severe stress will be doubled the next year. So that was probably the worst example of a carryover effect, that the carryover effect is even worse than the within year effect. But again, this is in almonds that bloom early, and so sometimes and the pollination and the initial crop set is all done in the relatively early spring when the weather's relatively mild. Even though you're not irrigating, they can still set a crop. So I think that all these questions you're asking about, exactly what to do if you're short of water, is going to depend on each individual crop type and how it develops its yield, and the carryover effects, just as you would expect, are going to depend on whether it's spur bearing or not spur bearing, and how much growth you actually need each year to maintain the bearing surface. All of those questions have to be answered to know how to manage the water.
So that was a question about the environment. Like, I would like to know, imagine a honeycrisp tree with the same roots of the same age. The only thing that they were planted, one in New York, the other one in Wenatchee, and the water usage of those trees, at least our tree, I think so a young tree used like 500 gallons per acre per day. A young apple tree. I don't know if the water need in Washington are double 25% to keep that plant physiologically active and moving nutrients and keeping and growing. So that why it's so important, all this kind of research.
And for questions like that, this is why I think you have to measure the plant, because it may surprise you. It may be under a lot more stress than you thought, or it may be under a lot less stress than you thought.
So Daniel, if we can be here until it's almost 8:50 here in the Northeast.
Yeah, so
I feel so lucky to have Professor Laxo, Professor Shackel. Like, this is amazing. Like, I know
we can keep going as long as people want to stay on. If you want to tune out, that's fine.
I should probably head home here pretty quick.
Yeah.
Yes. No, we really appreciate. I don't know if this is a closing remark, but Professor Shackel, last Friday you were so responsive, and we really appreciate. We thought that was a great idea to have you at the end of this series. Everything was an amazing amount of work of Bernardita. Okay, I want to recognize Bernardita. She did a tremendous amount of work this season. So we owe you a huge amount of gratitude, Bernardita. We learned a lot.
You're very welcome.
It's so much we want to learn from Washington growers, from BC growers. So we can learn and share it's not only through conference, or for us it's very expensive to attend ISTA conference, our growers. So it's another venue to share a little bit virtually between the best growers with the best scientists that we have access through our extension program in collaboration. So I feel very blessed to be able to do this, and we are learning. Dr. Shackel, you were asking how we want to start the first 2 slides or 3 slides. We are learning how to use this space to share information with the growers.
Yeah.
So thank you so much. Thank you so much.
I'm very impressed. Very impressed by all the.
We're trying. We're
yeah,
trying.
Good.
We're
good.
trying to share information because it's so much technology, so much microtension, Florida pool. Then there's so many things, so many ideas that how we can use the information, how we can adapt that information for the growers. Sorry.
Let me ask you a quick question here. Kevin, you're from Australia, is that correct? Did I hear you correctly? Are you down there now?
Yeah, that's correct, Daniel.
What time is it there for you?
It's really good timing, actually. It's, I think we started, and the local time here was 9:30 or 9 a.m. I was a little bit late to dial in.
Well, that's perfect. We'd love to have you back if you've got some recommendations. I think, Mario, you wanted to make this international. I mean, this whole discussion, you brought up something that
yes,
was not familiar to us here in the North America. So you ask how to get a hold of us, stay in contact, you know.
Yes.
To have some other countries represented here.
Yes.
If I can just add, Daniel, like from an Australian perspective, our capacity to invest in research on the scale that you do in the States is not possible for us. So, I've been working with the apple industry for a long time, and I've always valued being able to learn from what the US researchers are doing and the extension people. So, a big thanks from me and our industry.
Yeah.
Nice. Nice, Kevin.
Your gang down there is always welcome to join us.
Yes, we had to go.
I'll see you later.
Thank you, everybody.
Nice to meet you all.
Thank you, Victor.
Good morning, good day.
Thank you so much. Thank you so much. Thank you,
Victor.
Thank you, Alan.
Bye-bye.
Thank you, Alan. Thank you so much.
Thank you, Victor.
Thank you, Victor.
Victor.
Thank you. Bye.
Bye, man.